Matrices, determinant of a 3 by 3 square matrix. If we have a matrix A, sometimes written as Aij in brackets, and we would have the elements of that matrix, say A11, A12, A13, that's the first row, and the second row will be A21, A22, A23. That's the second row. So I got first row, first column, second column, third column. So I is for the row, J is for the column. Row 1, column 1, row 1, column 2, row 1, column 3. That's what this number stands for, Ij. A31, A32, A33. So the numbers are subscript. So that's a subscript, subscript, subscript. And we do that. All right, you might see matrix being written like that as well, using square bracket. We need to find the determinant of a matrix. So we write the determinant as A like that. That means the determinant, or you might write it as, and then you put A, that's the determinant. Put that in between two lines. That's what we call determinant. Each element has something called cofactor. This element here has a cofactor, that has a cofactor, that has a cofactor. And the way to find the determinant is to pick a row or a column. You can pick a column, or that row, or diagonal, and find its cofactor. Multiply the cofactor by the element. And then you do the same thing again. Find the cofactor of that, multiply that by the element, and then add that to the cofactor of that, and multiply that by its element of this. You add all those together, you get the determinant. You could do it for this one, or you could do it for that, or you could do it for that, but you need to do it for 3 of them, because this is a 3 by 3 matrix. If it's 4 by 4, you have to do it for 4. How do we calculate the determinant? Let's do it for the first 3 elements in the first row. Well, you find a cofactor of that, times it by the element, plus the cofactor of that, and times it by that element, plus the cofactor of that, and times it by that element, and that's the determinant. So the next question is, what's a cofactor? A cofactor of an element, so that's just referring to an element here. So it could be that, it could be that, it could be that. That's what this is. I is the row, J is the column. So a cofactor of an element Ij will be the sign of Aij times the minor Aij. That's how you find a cofactor. If I want to find cofactor of this one, which is this, and then I'll times it by that, and then I'll add on to the cofactor of this times this, plus cofactor of that times that, and that will be the determinant. What is a sign? And I'll show you how we get the sign. You need to know that the signs start with plus, minus, plus for 3 by 3. Well, let's start with 2 by 2. So 2 by 2 is plus, minus, minus, plus. But if it's 3 by 3, then that'll be plus, and that'll be minus, and then that'll be plus, minus, plus. If it's 4 by 4, the next one there will be minus, this will be plus, and that'll be minus, and this will be minus, that will be plus, and that will be minus. But we're looking at 3 by 3. So that means A11 has a sign of plus, A12 has a sign of minus, A13 has a sign of plus. So how do we calculate the sign? Well, as I said, the sign is calculated using this formula, -1 to power I plus j. So to calculate the sign for A11, that would be -1 to power of 1 plus 1, because 1 is that's the I, 1 there is j, and that equal to -1 to power of 2, which is -1 times -1, which is 1. So that's plus 1. So that's why we put here plus. So the sign for there is plus. And the sign for this one will be minus. So let's see, how do we get that to be minus? Well, if we do A12, so you can see A12 is that, or that, and that will expect that to be minus, and so equal to -1 to power of 1 plus 2, that will be -1 to power 3, that is -1 times -1 times -1, and that equal to minus or plus 1 times -1, which is -1. So that's why that's -1. So that's what that's -1. But this one is, you see, A13 will be -1 to power 4, and that will be positive. All the even numbers are positive, and all the odd numbers are negative. -1 to power 3 is negative. -1 to power 4 is positive. -1 to power 5 is odd, that's negative. -1 to power 4 is positive. -1 to power 5 is negative. -1 to power 6 is positive. So that's how we get those signs using this formula here. Okay, what about minor matrix? The minor matrix. To talk about the minor matrix, if you look at the element now, so let's look at this element A1 and find the minor matrix of A1. If I draw a line like that and like that to A1, the minor matrix will be this, that is not involved in the line. Any element that is not involved in that line will be the minor matrix. So that's what we're going to write down for the minor matrix of A11. So we could do that. All right, so let's write down the minor matrix now. So we say we know the sign now, the sign is positive, so we say +1, right? Let's put that in bracket, times the minor matrix. And the minor matrix here is A22, A23, and A32, A33. We do that. That's the minor matrix. So now I've got the cofactor of A11. So that's the cofactor of A11. The sign times the minor matrix. And you know how to find the minor matrix. Is a 2 by 2 here, determinant, that times that, minus that times that. That's how you find it. That times that, minus that times that. That will be the minor matrix there. So just to remind us what we just done, the sign is for A11 and the minor matrix is A11. So if we times that by the matrix itself, so that's times A11, the second part of the determinant will be, obviously we need to add that. We're going to add it to, the second part is A12, so that will be -1 because A12 here is negative. So -1. Let's put that in bracket, times, all right, I need to do the minor matrix of A12. Okay, so let's find the minor matrix of A12. So for A12, if I draw A12 there, and the lines to A12 there, and this one. So any other element that is not on the line will be the minor matrix of A12. So we're looking at A21, A31, A23, A33. So that'll be the minor matrix of A12. Okay, so let's write it out. That'll be A21, A23, A31, and A33. So the minor matrix of A12, you draw a line there, and there will be A21, A31, A23, A33. You want to times it by the element A12. So I've done the A12 and the sign is for A12. Cofactor here, that's the cofactor of A11, that's the cofactor of A12, and the cofactor of A11. Now I need to do the cofactor of A13, and I'll times it by the element A13. We got +1 for that. As you can see, that's +1 for A13. The sign is +1. Times that by the element minor matrix for that one. And the minor matrix for that, let's just draw a circle there. And the minor matrix will be these ones here. These are the minor matrix, because that any element that is not in that line will be the minor matrix. So it's a 2 by 2 here, because we're coming from a 3 by 3. So that would be you draw your line, and that's A21, A31, A22, A32, and then you want to times it by the A13. So we got the cofactor here. As a cofactor, and if you times it by the element, cofactor of A13 times the element A13, you get the final element to be added on. So that's the determinant of A. That's how you find the determinant of A. So you get the cofactor times the element of A11 plus the cofactor of A12 times the element of A12 plus the cofactor of A13 times the element of A13. And that's it. Every element has a cofactor. If I'm looking for that one, A22, all I need to do is draw a line there and there. The minor matrix of A22 will be A11, A31, and A13, A33. Every element has its own cofactor, and that will be useful when we're calculating the inverse of a matrix, because we need a cofactor and the determinant to find the inverse of a matrix. But for now, to find the determinant, we just do this. A matrix. So for that determinant, I then do +1 times the minor matrix, and the minor matrix is, so I'll do open bracket A33 times A22 minus A32 times A23. So that is this one here. That times that minus that times that. So that's how you calculate the minor matrix. And I need to times it by A11. So that will be times A11. The second one here is for that one here, for this one. So that's minus. Like you see, it's minus there. So we can say minus 1, put that in bracket, open bracket, A33 times A21, which we can get from here because we're doing this. So that's gone A33 times A21 minus A31 times A23. So minus A31 times A23, and then times it by the element matrix A12. And then next one is to add the next matrix element, so plus, and that would be this one here, which is A13. So for A13 I need to add that's plus 1, so that's plus 1. We don't need to put that in, but we can open bracket. We're doing that and that. You can see we're doing that and that, which is this one here. So it's A32 times A21 minus A31 times A22. A32 times A21 minus A31 times A22, close bracket, and why don't we make that smaller to have more room? And then I need to times it by the element, times the element, which is A13. And that's it. So what we now need to do is to do an example for calculating the 3 by 3 matrix. So we got an example here. A equals 5, 2, 1, 0, 6, 3, and 8, 4, 7. That's the matrix. A good idea is to remember that this is A11, A12, A13, A21, A22, A23, A31, A32, A33. And also to remember that we have the plus, minus, plus the sign, minus, plus, minus, plus, minus, plus. And those are the sign. So we need a cofactor times the sign times the element. That's it. And what we need to do for, we need to do for either that or that or that or that or that or that. You choose. It's up to you. But I'm choosing this because I got 0 here. So that means something will be eliminated. So that may be quicker for me. So I'm going, because I'm going to times it by the element, and that element here is 0. So one of them is gone. All right. So it makes life easy for me. Okay. So what we're going to do now is let's make that smaller a little bit so we can see what we're doing now. Good. And what we're going to do now is, so now let's write the A determinant, which can be written as determinant A, and we just dot a line there and a line there, and we populate it with a value matrix 5, 2, 1, 0, 6, 3, 8, 4, 7. And to find the determinant, we're going to do the sign, which is plus, times the minor matrix. And so that means I draw the line there, and draw that line. So my minor matrix are 2, 1, 4, 7, because I'm looking at that. So for the 0, the minor matrix will be, well, the sign here is minus because I'm looking at that, and that's the sign for that. So it's minus 1, and the minor matrix, 7 times 2 minus 4 times 1. 7 times 2 is 14, 4 times 1, 4. Okay, that's good. But I'm going to times it by element, which is 0. So that's the first one. Then I'll do plus the next one, this one here, which is plus 1 times, well, because I'm doing 6. So that is 6 here. I've got that, and I'll do that and that. So my minor is 7 times 5 minus 8 times 1. In bracket, 7 times 5 minus 8 times 1. And then I need to times it by the element, which is 6. So why don't we make that smaller to have room for ourselves? Okay. Well, next one I need to do is minus, because I'm doing this one, 3. So I'm doing that row. So that 3 is minus. Now I need to do minus 1 for the sign times the minor matrix 3. So the minor matrix are 5, 2, 8, 4. 4 times 5, 20, minus 2 times 8, 16. Open bracket. 4 times 5, 20, minus 8 times 2, 16, times the element 3. And so that's what we needed. And we need to finish it off. And that will be equal to, well, we got minus 1 here times 10 times 0 plus plus 1 here, so plus 1 times, that's 35 minus 8 times 6 plus minus 1, so that's 4, so that's minus 1 times 4 times 3. So that'll be 0 plus, well, 25 minus 8. 25 minus 8 is 27. 27 times 6 is 162. That's 162. And then plus, that one is minus 1 times 12. 4 times 3 is 12. So that means plus minus 12. 0 plus 162 minus 12, and that is 150. The determinant of A, which can be written as det of A in bracket, is 150. We could try another example. If we have another matrix, A equals to 3, 2, 5, 4, 7, 9, 1, 8, 6, and we are looking for the determinant of that matrix, we need to remind ourselves A11, A12, A13. You don't need to do that all the time. A21, A22, A23, A31, A32, A33. We're just identifying the elements, and they have a sign which is plus, minus, plus, minus, plus, minus, plus, minus, plus. So to find the determinant, we say A equals to, well, 3, 2, 5, 4, 7, 9, 1, 8, 6, which, if I write that down clearly, let's give ourselves more room to do the matrix. So that's the matrix. Now we got to find the cofactors and multiply it by their element. So I'm going to do the first row here. Determinant of A will be plus, that is a major matrix, that is a minor matrix for that element. 7, 9, 8, 6. 7 times 6 minus 8 times 9. That's what we're going to get. So I'll get plus 1, open bracket, 7 times 6 minus 8 times 9. That's the first one. And I need to times it by the element. The element of concern is 3. So I'll times it by 3. And then next one will be plus second element, which is 2. And 2 is minus 1. And then the element I'm looking for, this is 2. So that's 2. And the element I'm looking for are 4, 9, 1, 6. So that would be 6 times 4 minus 1 times 9. And then times 2. And then plus the next one, which is 5. This is the 5 here. And so again, I'm looking for that and that. So this is the minor matrix for 5. There's a minor there. So I need to then do, and the sign for that is plus. So I'll do plus 1, open bracket, 4 times 8 or 8 times 4 minus 1 times 7. And then it times it by 5, the element. Okay, that would be 1 because that's 1 there. I got 7 times 6 is 42 minus 8 times 9 is 72 times 3 minus, because this is minus here, minus there, 4 times 6, 24 minus 9, I'm getting 15 there. 24 minus 9 is 15, and 15 times 2 is 30, so that will be minus 15 times 2 plus 8 times 4 minus 7. 8 times 4 is 32. 32 minus 7 is 25. 25 times 5 plus 25 times 5, and this is 25 and 1 is here. Okay, we have 42 minus 72 minus 30. Minus 30 times 3, that will be minus 90 minus 30 again, because 15 times 2 is 30 minus plus 125, and that gives minus 120 plus 125, and that is 5. Determinant of A is 5. If you have a matrix equal to 2, 0, 0, 0, 5, 0, 0, 0, 4, and then we need to find the determinant. Again, don't forget that we have plus, minus, plus, minus, plus, minus, plus, minus, plus. The determinant of A is equal to, well, it doesn't matter which one we do here. You can see there's always 2 zeros in each one of them. So I'm going to do the first row. Plus, so that'll be 5 times 4, because if I take that row out, I'm left with this. These are the minor metrics here. So I would say that it's 5 times 4, which is 20, minus 0 times 0, that's 0, times 2, so plus minus 1, open bracket. Now I'm doing that one, so that goes and that goes. So I got 0 and 0, 4. 0, 0, 0, 4. So 4 times 0, 4 times 0 minus 0 times 0. And then times the element that in concern, which is that one, and that'll be times 0. And then next one will be plus, and we're adding that here, that one, that's a plus. It will be plus 1, open bracket. So I'm doing that and that. So what's left is the 0 zeros, 5 0. We're going to do 0 times 0, 0 times 0, which means 0 times 0 minus 0 times 5, right? So that'll be minus 0 times 5. And then times the element concerned. The element is 0 times 0. 20 minus 0 is 20 times 2, that's 40. Plus or minus, plus times minus is minus. 4 times 0 minus 0 is 0 times 0, so it's all 0 minus 0, and plus 0 times 0 minus 5 times 0, that's 0, and that times 0 is all 0, plus 0, and we get 40 for the determinant of A.